Hey, algebra students. Last time we discussed the holy trinity of algebra: tables, graphs, and equations, and connecting those three together. And so here in lesson 2, we're going to be taking tables and graphing from those. And so we'll get a variety of different ways that we can do that. Before we get into, I guess, forming with tables, exactly like you're going to see it in the lessons and whatnot, this special case, which confuses students all the time. We have y equals 4, and then here we have negative 2. Now typically, when you see an equation to graph, you're going to see it this one, which is called standard form, or you'll see them like this, which is like slope-intercept form. Okay, but these ones aren't really in either form. They're just a little bit weird. The common mistake that I see is that students will just say, all right, y equals 4, and they'll graph me a little dot here at y equals 4, which I can understand why you would make that mistake, but this dot right here is not y equals 4. That dot is actually 0.04, and so yeah, don't do that. That's not the right thing. A table can help us figure out precisely how to do this. So if we did x and y, well, here's the thing: when x equals 0, y equals 4. When x equals 1, y equals 4. When x equals negative 3, y equals 4. And in fact, every x value, y equals 4. So if I graphed a bunch of these, 1, 4, negative 3, 4, all of these, in fact, would make a line. And so when you see the instructions graph y equals 4 or y equals anything, well, it's the horizontal line. Okay, and if you make a little table, you very easily see that. If you just want like a quick thing, I always remember it is when I see y equals 4, it goes through the y at 4. Now, when you see x equals something, in this case x equals negative 2, okay, you kind of do the reverse thing. Say y equals 0, what does x equal? Negative 2. When y equals 1, what does x equal? Oh, negative 2. When y equals 3, what does x equal? Oh, negative 2. And so what happens here is I got negative 2, 0, negative 2, 1, negative 2, 3. And so, you guys, and I put all of these dots together. Okay, what I wind up getting is a vertical line. So every time you see x equals something, you're going to get a vertical line. So again, the way I remember it is when I see x equals negative 2, that is the line that goes through the x-axis at negative 2. So again, try to avoid making that big error of just drawing a dot. Again, it's not the same thing. The dot is negative 2, 0, not x equals negative 2. Okay, well, let's move on to some of our more traditionals. So you mentioned earlier, this is what's known as standard form. So x plus by equals c is called standard form. We're going to talk more about that in lesson 3. And so we are going to graph this using a table. We'll learn how to do it without a table. But it also gives us the clarifier that the domain is x. Is a good idea to start with 0. I don't need any negative numbers for this particular graph. And maybe I'll just pick a couple of easy numbers like 1 and 2. Well, I guess what we'll do here is we're going to plug in 0 for x, and then we're going to have to solve for y, get that value. Well, 0 is a good number because 4 times 0 is 2, y equals 2. So it helps to be kind of fast at solving these equations. Let's see, when x equals 1, I get 4 times 1 plus 2y equals 2. Again, I'm trying to solve for y. So I get 4 plus 2y equals 2. Subtract 4 from both sides, and I get y equals negative 2. 2 minus 4 being negative 2. Divide both sides by 2, and get y equals negative 1. All right. So let's see, let's try one more. I'm going to plug in 2 for x, 4 times 2 plus 2y equals 2. So I've got 8 plus 2y equals 2. Subtract 8 from both sides. Now I've got 2y equals negative 6. Divide both sides by 2, and negative 3. All right, well, now that I've got these coordinates, they 0, 1, and then 1, negative 1, and 2, negative 3. Now again, just a tip, okay? If you are doing this and you get something that's not a straight line, you did it wrong. You need to go back and fix it, okay? So make sure that you're getting straight lines when you graph. All right, now the last one that we'll see today, we've got something that's called slope-intercept form. Again, we'll talk about this later on in the unit. 2x. So the generally speaking, say y equals mxb. Okay, but here, okay, again, we're going to do this specific domain, x less than or equal to 2. So I might say something like 2, 1, 0. Because I want less than or equal to 2. And I guess that actually reminds me, if I wanted a domain of x greater than or equal to 0, well, actually according to my graph here, I have values of 0, so I would actually cross these off. I don't want any of those, I just want it starting right here. Okay? So I'll try to remember that this time. Okay, let's pick these values out. So if x equals 2, again, I need to find value. So 2 times 2 is 3. These ones are a little bit easier to figure out. Is 2 times 2 minus 3 is 1. So y equals 1 when x equals 2. I'll plug in the 1 now. So y equals 2 minus 3. Give me 2 minus 3, which is negative 1. And then when x equals 0, say 2 times equals 2 times 0 minus 3. Well, 2 times 0 would be 0. 3 is negative 3. So when I graph these points, I've got 2, I've got 1, negative 1, and 0, negative 3. Now let's be a little more careful this time. Domain is less than or equal to 2. So here's x equals 2. I want values less than that. That would be all of these right here. Okay. All right, well, there's graphing using a table. Pretty much the remainder of this unit will be showing you how to graph without using a table.